Okay, the quiz. It's now too late to turn it in, as you know. Okay, so some of you gave me a graph, but that was it. I can't accept that. There are graphing calculators out there that we know, and you can just punch some buttons on your calculator and it'll give it to you. This is not a calculator course. So now I don't mind that you use your calculator for double check, but you can't use that as your primary source of getting the answers. So you give me the zeros. The zeros are 0, 1, and -2. 0, 1, and -2. And then after that, a chart of in-between points and end behavior. End behavior means after the last zero, so in my case 2, and before the first zero, so in my case -3. And then something in between here like -1, and something in between like 0.5. Okay, so then I just made a little sign chart. So I got -3, -1, 0.5, and 2. Okay, so x squared, x minus 1, x plus 2. Notice x squared is always positive, so I just put pluses all the way down here. -3 minus 1 is negative. -3 plus 2 is negative. So a positive times a negative is a positive. So that means I know it goes up. That means it goes to infinity. That's so-called end behavior. Once you go past the first zero on the left or to the right of the last zero on the right, you either shoot to infinity or negative infinity. So positive means infinity. Okay, -1, we already said that was positive. -1 minus 1 is negative. -1 plus 2 is positive. So what's a positive times a negative times a positive? It's negative. So that means it goes down. So it goes down and back up. Now, I don't know how far down it goes. Some of you gave me a more accurate description, maybe from a graphing calculator, I'm guessing. And you said this was going lower than this. Well, right now, we don't know how to get that. You'll learn techniques like that in calculus. So when you guys take calculus, you'll learn that. But for now, all we can say is it's negative. I mean, I drew it coming down here. We don't know if it goes down quite a bit and then comes back up, but that's okay. All right, 0.5, positive. 0.5 minus 1 is a negative. 0.5 plus 2 is a positive. So once again, you have a positive times a negative times a positive. That's a negative. So it goes down and up. Yeah, I drew it so that these are both the same distance down. We don't really know that. In fact, some of you knew when you punch it in a graphic calculator, it does go further down here, but right now we can't tell. And plug in 2, everything's positive. We already said that's positive. 2 minus 1 is positive. 2 plus 2 is positive. Positive times positive times positive, positive. So it shoots up. Okay, and then number 2, I did the long division. If you did synthetic division, that's fine also. It'd probably be faster. You want to be comfortable with both methods. And by the way, when it comes to our next test, be ready for both long division and synthetic division. I might ask you for both. All right. So the whole thing, x cubed minus 3x squared plus 3x minus 1, x minus 1. Okay, it comes out to be x squared minus 2x plus 1. You could have stopped there. Some of you kept going and factored that further. It was actually x minus 1 cubed. That's okay. That's over and beyond the Call of Duty. But if you did it, I don't mind. Okay, process. X goes into x cubed, x squared. Then x squared times this whole thing is x cubed minus x squared. Subtract, that cancels out. -3 minus a minus 1 is -2x squared. Bring down to 3x. Okay, how do you go from x to -2x squared? Multiply by -2x. Then -2x times this whole thing, -2x squared. -2x times -1 is 2x. Subtract. -2x squared minus a minus 2x squared. That cancels out. That's like plus 2x squared. 3x minus 2x is 1x. X minus 1. X minus 1. How do you go from x to x? 1. 1 times that is that. Subtract, no remainder. So x squared minus 2x plus 1 is the answer. Okay, so that's it for the quiz. And we're done with the quiz. Okay, so calendar. We're just about right on par. So here's today, the 28th, 3.4. I'm right on par, but we do have some buffer days at the end in case I fall behind. So again, buffer day doesn't mean a holiday. It means keep going in case something goes wrong. You know, my computer goes out, my internet goes out, I get sick or whatever, and there's extra days. So aiming for a quiz again this Friday. That would be October the 2nd. How do you like that? It's almost October. And then our next exam will be Friday the 9th. That would be exam 3 out of 6. So that means after next Friday's exam, we would be halfway through the course already, believe it or not, because that would be halfway through right here. Okay, so that's where we are. And looking again at our assignment, so we are right here, 3.4 when the 43 are. Okay, so I'll do some more problems from 3.4, and let's see how far we get. Right, so 3.4, page 169. So we are trying to do more of this kind of stuff. Okay. So last time I did some problems up to here. So I'll show you some problems from here. Sketch the graph labeling any horizontal and vertical asymptotes and intercepts. Okay, so I definitely want to show you some of those. And then if time permits, we'll do some of this, but we'll see how it goes. Okay. So 17, please. F of x is equal to 3 over x minus 2. All right, so VA stands for vertical asymptote. HA stands for horizontal asymptote. You can use the same abbreviations, so you don't have to write the whole thing. Okay, so you write it, vertical asymptote. VA. And horizontal asymptote, HA. All right, so for vertical asymptote, it's pretty easy. You just say to yourself, well, what number is not allowed here? X equals 2. Now, you do have to be a little bit careful. That's not quite true for problem 25. 25 is a little bit different. Okay, we'll worry about it when we get to it. But X equals 2. Okay, horizontal asymptote, you say what happens when X gets super big? Okay, if I plug in a super big number, 3 divided by a super big number is practically 0. Okay, you should not need your calculator for that. Okay, if I plug in a million minus 2, it's 999,998. It's essentially a million. 3 divided by 999,998 is practically nothing, right? It's like if you have 3 pizzas and you have to feed 999,998 people, everybody pretty much gets nothing. Okay, so horizontal asymptote, y equals 0. So y equals 0 is a horizontal asymptote. X equals 2 is going to be a vertical asymptote. Okay, remember, vertical asymptote, you're always going to have x equals whatever. Horizontal asymptote is always y equals something. Okay, if you want a little memory trick, and if you look here, VAX, it's kind of like VAX. I don't know if that's a real word, VAX. Maybe short for vaccine. We're looking for a vaccine now, right? VAX. And a memory trick here is hay, H-A-Y. Okay, vertical asymptote is x equals blah, blah, blah. Horizontal asymptote, y equals blah, blah, blah. Okay. All right, the intercepts. Intercepts means plug in x equals 0, plug in y equals 0. Okay, x equals 0, put a 0 right there. It's like it's not even there. So that gives you -3/2. So 0, comma, -3/2. Okay, so I put that over here. Y equals 0, I crossed it out. And why did I cross it out? Okay, if you put a 0 here, 0 equals 3 over x minus 2. Okay, now remember, when is a fraction equal to 0? A fraction is equal to 0 when the numerator is 0, when the top is 0. But the top is already 3, so you can't do any more with that. Okay, so that's impossible. Okay, so if you have 0 equals 3 over x minus 2, it's impossible. Okay, so this can't happen. So y cannot equal 0. In fact, we already know y equals 0 is an asymptote. Okay, that pretty much does it. Now, what about here and over here? Well, you could plug in a number very close to 2 on the left and on the right. Okay, so let me show you that right now. So I'm going to write x approaches 2 coming from the right. X approaches 2 coming from the left. Okay, so the plus means coming from the right. The minus means coming from the left. It doesn't necessarily mean positive or negative numbers. Okay, in fact, in this particular case, if I pick numbers that are near 2, they're always going to be positive. Okay, this means 2.1, 2.01, 2.001 coming from this side. This means coming this way, so 1.9, 1.99, 1.999, and so on. Okay. So I'm going to write what does y approach. You're going to use this symbolism quite a bit when you get to calculus again. Okay, so 2.001. 2.001 minus 2 is a very small positive number. Okay, so 3 divided by small positive is a big positive. So y approaches infinity. So we know it shoots up like that. And I already know that y equals 0 is a horizontal asymptote. Okay, it's going to be positive. So again, if I plug in 1,000,000, this is a very small positive quantity, so it stays above the x-axis. Now, if I plug in a number like this, 1.999, 1.999 minus 2, you should not need a calculator for this. It's a very small negative number. So 3 divided by a very small negative is a very large negative. So negative infinity. All right, so if I come this way, I approach 2 from the left, it shoots down to negative infinity. And it touches here. And this time we know it approaches y equals 0 from below. If I plug in negative 1,000,000, 3 divided by a super big negative is a super small negative. So it stays a little bit below the x-axis. So that's my entire graph in this particular case. All right, so that's how you would analyze graphs like this. Okay? So find the asymptotes, any intercepts, and then see what happens when x gets super big, either positive or negative, and what happens when x approaches any asymptote, coming either from the left side or the right side. Okay? You'll see this concept a lot more when you get to calculus. But we get real close to 2. See, I'm not allowed to plug in 2, right? 2 is not allowed. But numbers very close to 2 are allowed, like 2.001. That would be here, a little bit to the right of 2. And 1.9999, that's a little bit to the left of 2. But notice it's not a negative number. It's a positive number. Okay, so the plus or minus doesn't necessarily mean a positive or negative quantity. All the numbers I'm plugging in now are positive quantities. Okay, we're just talking about getting real close, either from the left side or the right side. Okay, next one is 21. 21, they give you this. 2x minus 1, x plus 2 over 3x plus 1, x minus 3. So there's a lot more going on here. How do we come up with a graph of this? Okay, first, I want you to recognize that both of these are second degree. Okay, this is going to be 2x squared plus blah, 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 right? If you FOIL it out. This is 3x squared plus blah, 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 if you FOIL it out. Okay. And the idea is this. When x gets really, really big, the x term and the constant term drop into insignificance. They don't matter. There's going to be blah, blah, blah x, and then a number. Oh, we know what the number is. It's going to be negative 2, right? This is going to be 3x squared plus something with an x and something with a number. They drop into insignificance when x gets really big. When x gets really big, these are the dominating terms, right? These fall way behind. So you're essentially just looking at this. Okay, so what's 2x squared over 3x squared? It's 2/3. Okay, so y equals 2/3 is going to be a horizontal asymptote. Okay, so one more time. When both the numerator and denominator are the same degree, they're both second degree, or they're both third degree, or they're both first degree, or they're both fifth degree, or whatever. Okay, then just look at the leading coefficients, ignore everything else, okay, and y equals 2/3 will be a horizontal asymptote in this particular case. All right, so y equals 2/3 is something like this. It's 1.5. All right, now vertical asymptotes. Okay, well, just look at the denominator. Okay, what numbers are not allowed? Okay, do a little bit of algebra here. X equals negative 1/3. A little bit of algebra here. X equals 3. Okay, so vertical asymptotes, VAs, are x equals negative 1/3 and x equals 3. And you have a horizontal asymptote, y equals 2/3. So the graph will get real close to 2/3 as I go all the way out to the right and also as I go all the way out to the left. All right, how do I do the rest of the graph? How about let's plug in x equals 0. Okay, if x equals 0, put a 0 here, 0 here, 0 here, 0 here. Okay, it really means ignore that and ignore that, right? So you have -1 times 2 divided by 1 times -3. That is 2/3. So I have 0, 2/3. Oops, 0, 2/3 over here. All right, Y-intercepts. Sorry, X-intercepts. Okay, Y equals 0. So put a 0 here. When is a fraction 0? When the top is 0. Okay, ignore the bottom. So what makes this 0? What makes this 0? Okay, I trust you can do that algebra. X equals 1/2. X equals -2. So 1/2, 0, -2, 0. Okay, so I plot down the intercepts. Here's 0, 2/3. That says 2/3 there if you can't see it. Make it a little bit better. 0, 2/3. -2, 0, and 1, 0. Okay, now the tricky stuff here. X approaches -1/3 from the left and from the right. And X approaches 3 from the left and from the right. Okay, this is going to be a little bit tough. Okay, -1/3. Well, it might be better to think of this as a decimal. Okay. -1/3 is -0.333333, something like that. Okay, so maybe to figure that one out, let's pick a number smaller. You can pick something like -1, I suppose. That's close enough. We could pick a decimal, but I don't really feel like doing that. -1 should be good. Okay, so I'm going to plug in -1 everywhere and get the sign. 2 times -1 minus 1. That's a negative. -1 plus 2 is positive. 3 times -1, -3, plus 1 is a negative. Okay, I don't care about the exact value. I just want the sign. -1 minus 3 is a negative. All right, so I have 1, 2, 3 negatives. 3 negatives means the whole thing is negative. All right, so that means y approaches -infinity. So if I come on the left side to -1/3, it drops to -infinity. All right, now I approach -1/3 coming from the right. Well, a real nice number is 0. I could do the same sign chart, but see, wait a minute, I just did 0. 0 is 2/3. It's positive. So yes, I could put the sign chart, but I already know it's positive. So coming from the right side, I approach positive infinity. Okay, so when x approaches -1/3 from the positive side, yes, I could do the sign chart, okay, but I don't need to. I already plugged in 0, which is a little bit to the right of -1/3. It shoots up like crazy. Okay. So again, when I approach an asymptote, either from the left or from the right, it's either going to go to infinity or -infinity. Okay, one or the other. So y approaches infinity. All right, 3. I approach 3 coming from the left, also coming from the right. So a number a little bit smaller than 3. I mean, ideally, that would be like 2.9999, something like that. But 2 should be fine. Let's plug in 2. 2 times 2 minus 1, positive. 2 plus 2, positive. 3 times 2 plus 1, positive. 2 minus 3, -1. So I have 1 negative, leaving with a negative. which means y approaches negative infinity as I approach 3 from the left. That means coming on this side. When I get close to x equals 0 on this side, the function drops down. Okay, so I can connect this now. On this side, it goes way up, touches here, touches there, goes all the way down. All right, and then I approach 3 coming from the right side. Unfortunately, I can't show you both at the same time, but the calculations are easy. Let me plug in a number like 4. That's to the right of 3, right? Number to the right. Everything's going to be positive. You can see, hopefully you can see everything's positive. 2 times 4 minus 1 is positive. 4 plus 2 is positive. 3 times 4 plus 1 is positive. 4 minus 3 is positive. Everything is positive. So y approaches infinity. All right, so here we go. We got the graph. This side shoots up. This side it gets real close to y equals 2/3. This side goes up. This side goes down, touches these 2 points. This side goes down, touches negative 2, 0. This side gets real close to y equals 2/3. Okay, there's a lot of work for these kind of problems. Okay, where we're analyzing what happens when I approach a number from the left side or from the right side. Okay, so again, you can see there's a lot going on here. Okay, 25 is a little bit more tricky. Okay, so x squared plus 2x minus 3 over x minus 1. Okay, now, at first glance, you might say, oh yeah, x equals 1 is going to be a vertical asymptote, but not quite, because I can cancel out the x minus 1. If you factor the numerator, how do you get 3? Well, 1 and 3. X squared is x times x. And you want a positive 2, so positive 3 and a negative 1. Double check by FOIL. X squared plus 3x minus 1x is 2x minus 3. And notice these cancel out. So I just have x plus 3, but this is the function. This function does not allow for x to be equal to 1. So I need to say x plus 3 is the same function as long as x is not equal to 1. Okay. And by the way, what do you get when you plug in 1? You get 4, right? 1 comma 4. All right. So I know what's the graph of this. It's a straight line. I'll graph it, except there's a hole at 1 comma 4. I have to throw out 1, 4, in other words. So there's the graph. Okay. So if I were to graph only y equals x plus 3, right? Y-intercept is 3. Slope is 1, over 1, up 1. So I graph this entire line, but just punch a hole right at the point 1 comma 4. Because ultimately, this is not the function. This is the original function, right? And when you plug in 1, you can't because you're dividing by 0. So it's a little bit tricky. So even though x cannot be 1, okay, it's not going to be an asymptote. I can still do the intercepts. That's easy. What do you get when x is 0? 3. And what do you get when y is 0? Again, f of x is 1. Put a 0 right here. 0 equals x plus 3, subtract 3. So x is equal to negative 3. Okay, so there's negative 3, 0, 0, 3. There's the graph, which is the entire line, y equals x plus 3, except I punch a hole at 1 comma 4. Right there. All right, so don't automatically assume that you have an asymptote wherever the denominator is undefined, because you might be able to cancel that out with something like this. Okay. Now, that wasn't possible here, right? No cancellation for x minus 2, so x equals 2 is an asymptote. Same thing for this one. Okay. There's no way I'm going to cancel out that or that with something on top. So I do have 2 asymptotes vertically. X equals negative 1/3 would force this to be a 0. X equals 3 would force this to be a 0. But in this case, since I have a cancellation, right, x equals 1 would not be a vertical asymptote. Okay. Okay, then 29 is the next one I want to show you. And that one's on the next page, I think. Yeah. It's on the top of 170. 3x minus 2 over x squared plus x minus 6. All right, and let's factor the bottom. Okay, x squared is x times x. What two numbers have a product of 6 and a difference of 1? 3 and 2. You want it in with a positive, so plus 3 minus 2. And there's no cancellation. So the vertical asymptotes are, what makes this a 0? Negative 3. What makes this 0 is 2. So vertical asymptotes are x equals negative 3, x equals 2. Okay, you must put the x equals blah, blah, blah. That's the equation of a vertical line. Okay, again, if you want a memory trick, I suppose, or you can just put an example on your cheat sheet, but VAX, V-A-X, and hey, right? Horizontal asymptotes, y equals something. Vertical asymptote, x equals something. All right, how do you get to horizontal asymptote? Okay, maybe look back here. This is first degree. This is second degree. Okay. Again, for a very, very, very big x, the negative 2 is insignificant. The x minus 6 is insignificant. It's basically just this. And if it's just this, you can cancel out an x. You have 3 over x, right? So what happens to 3 over x when x gets super big? The bottom wins. Okay. Again, x squared beats 3x any day, right? Like if you plug in let's plug in a billion. 3 billion, that's pretty big, but a billion squared is way bigger. Right? A billion squared is much, much bigger than 3 billion. Okay. So the ratio is 0. So horizontal asymptote is y equals 0. So yeah, if you just want to generalize, if the degree of the denominator is bigger than the degree of the numerator, the bottom's going to win. So y equals 0 will automatically be an asymptote. Okay, so I don't think you have to write that down if you know what's going on. Okay, so if this is x to the 6th, this is x to the 4th. X to the 6th is going to win in the long run for super, super big x. So y equals 0 in the long run. All right, then intercepts. Plug in x is 0. Put a 0 right here. Put a 0 there. 0 there. Well, 0 means they're not even there. It's basically negative 2 divided by negative 6, which is a positive 1/3. 0, 1/3, right? And how about y equals 0? So plug in y equals 0. When is a fraction 0? When the top is 0. So ignore the bottom. 0 equals 3x minus 2. A little bit of algebra. X equals 2/3. Okay, so 2/3, 0. All right, so I have an intercept at 0, 1/3 right here, and 2/3, 0. When x gets super big, y approaches 0. When x gets big negative, y approaches 0. But from below, it's a little bit below, so that's why I'm putting this now. X approaches infinity, y approaches 0. Plus means from above. It's a little bit above. Okay, if I plug in a super big positive number, again, ignore these. These are insignificant. It's a positive quantity, right? If I plug in a million, positive, positive, but this one wins, so the ratio is almost 0. But from above. Now over here, when x goes to negative infinity, I have y approaching 0 from below. Okay, well, if you plug in a super big negative number, plug in negative 1 billion, you can ignore everything besides the leading terms. Negative 1 million. This is negative. Negative 1 million squared, however, is positive. Right? So if I have a negative divided by positive, I get a negative. So y approaches 0 from below. A little bit below. All right, then I have to analyze what happens when x approaches negative 3 from the left and right, and what happens when x approaches 2 from the left and right. So that is this analysis now. Okay. So I pick a number to the left of negative 3, to the right of negative 3. That's what that means. To the left of 2 and to the right of 2. Okay, so let's try negative 3. A little bit to the right would be, let's say, negative 4. Okay, plug in -4. Okay, without doing too much, I hope you can see that everything is negative. Okay, 3 times -4, -12, minus 2 is negative. These two are also going to be negative. -4 plus 3, negative. -4 minus 2, negative. So I have a negative divided by a negative times a negative. 3 negatives, so that means y approaches negative infinity. So if I'm coming toward -3 from the left side, we drop to negative infinity. So that's the way the game is played. Okay, how about I approach -3 coming from the right side? Well, I could just plug in 0 where I've already done it. Okay, I already know it's positive. Right? Okay, but if you want to do a sign analysis, plug in 0. 3 times 0 minus 2, negative. 0 plus 3, positive. 0 minus 2 is negative. Okay, so it was negative, positive, negative. So I have 2 negatives. That means the whole thing is positive. Y approaches infinity. Okay, so that means on this side, shoots up like that. Okay, then I do the same thing to the left of 2 and to the right of 2. To the left of 2, I want to know, does it go down to negative infinity or does it shoot up to positive infinity? Same thing over here. Okay, so a number that's bigger than, smaller than 2. This symbol means smaller than 2. Okay, so like 1. Okay, so plug in 1. 3 times 1, 3, minus 2, positive. 1 plus 3, positive. But 1 minus 2 is negative. So I have 2 positives and a negative. That makes the whole thing negative. Y approaches negative infinity. So graph shoots down. And then a little bit to the right of 2, let's try 3. Okay, everything's going to be positive. Okay, plug in 3. 3 times 3 minus 2, that's positive. 3 plus 3 is positive. 3 minus 2 is positive. Everything's positive. So positive divided by positive times positive. It's positive, so y approaches positive infinity. Right? So a little bit to the right of 2, y approaches positive infinity. There it is. So we have the whole graph. So when x gets super big, we approach 0 from above, a little bit above. When x approaches negative infinity, I go way out there. It also approaches 0, but a little bit from below. Okay, we analyze coming from the left of -3, we approach negative infinity. So I'm approaching -3 on this side, drop to negative infinity. If I approach -3 from the right side, though, it approaches positive infinity. That's what this symbol means. And then 2. If I approach 2 from the left, we drop toward negative infinity. That's what this means. And when we approach 2 coming from the right, we jump up toward positive infinity. So approach 2 coming this way, you shoot it like so. Okay. So that's the analysis of these. These rational functions are much more difficult, as you might anticipate. They're not that nice, so to speak. Okay. I'll only go a little bit longer. I want to talk a little bit more about the idea of a slant asymptote. Okay, so I showed you this from the text last time, a little bit. Page 164. A slant asymptote. So we can have a vertical and a horizontal asymptote. How about a slant asymptote? Okay, we have a slant asymptote when the degree of the polynomial p of x is exactly 1 greater than the degree of the polynomial q of x. So the numerator is exactly 1 higher than the denominator. We will have a slant asymptote. We can figure it out by the division algorithm. So we'll do the division, long division perhaps, okay, and it'll give us a slant asymptote. Okay, so that means something like this. So the top is 3x cubed, the bottom is 7x squared. Okay. We will have a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. Exactly 1 more. Okay. So this is a cubed, that's a 3 there if you can't read it, sorry. 3x cubed plus blah, 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 divided by 7x squared plus blah, blah, blah. The blah, blah, blah can be anything. You know, something with x squared, something with x, and a constant. This is 7x squared, maybe that's minus 5x plus 2 or whatever. Okay, this will have a slant asymptote because this is 3rd degree, this is 2nd degree. Another example is negative 4x to the 7th plus blah, 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 doesn't matter, divided by 3x to the 6th plus blah, blah, blah. All right, so 7th degree, 6th degree, you will have a slant asymptote. So the degree of the numerator is exactly 1 more than the degree of the denominator. Okay, so let me show you the setup for 37, and maybe that's all we have. Okay, so 37 says f of x equals x squared over x minus 1. Okay, 2nd degree, 1st degree. Right? So we will have a slant asymptote. Right? The degree of the numerator is exactly 1 more than the degree of the denominator. 2nd degree, 1st degree. All right, so first I'm going to do the division. Okay, I decided to do synthetic division this time. When you do that, you have to remember that x squared means x squared plus nothing plus nothing. Okay. X squared means x squared plus 0x plus 0. So there it is, 1, 0, 0, meaning this 0. Okay, so this corresponds to this. This is x and 1x squared. And I'm dividing by x minus 1 means you put a positive 1 here. Okay, then I do the division synthetically. So bring down to 1. 1 times 1 is 1. Add 1. Multiply. 1 times 1 is 1. Add 1. So my remainder is 1. Okay, so x squared divided by x minus 1 is x plus 1 plus 1 over x minus 1. Okay, so this is 1 over x plus 1. So that is the same as this. Okay, now here's the logic. When x gets super big, either positive or negative, if I plug in 1,000,000 or negative 1,000,000, either case, this drops into insignificance. So you essentially have y equals x plus 1. Okay, so way out to the right and way out to the left, the function looks more and more like y equals x plus 1. So y equals x plus 1 is going to be your slant asymptote. Okay, so I've got it slanted going like this. Okay, so I'm going to get real close to this line. Okay, when x gets super big, this is like nothing. And when x gets super big negative, this is also like nothing. All right, so here's y equals x plus 1. My b is 1, y-intercept. My slope is also 1. So it goes up at a 45-degree angle. Okay, intercepts. What do you get when you plug in 0? 0. It touches the origin. Okay, then I just analyze what happens when x approaches 1, either from the left or from the right. So I analyze this. Okay, so a number a little bit to the left of 1, like 0.99. Okay. By the way, notice numerator is always positive. So the sign is completely determined by the denominator. Okay, so if I plug in 0.999, that's positive. What's 0.99 minus 1? 0.99 minus 1 is a very small negative. So positive divided by negative is a negative. Okay, y approaches negative infinity. Okay, so on this side, it shoots down. And then something a little bit to the right of 1. So x approaches 1 from the right. That's like 1.01, something like that. Okay, so if I plug in 1.01, the top is always positive. 1.01 minus 1 is a very small positive. Okay, so y approaches positive infinity. All right, so on this side, it shoots up. So there we go. If I approach 1 from the left, touches the origin, shoots down. On this side, however, X approaches 1 coming from the right, it shoots up. And now going way out here or way out here, we approach the slant asymptote, slanted asymptote. So it shoots up like so, and it shoots down like so, because we have a slant asymptote this time. Okay, so we don't approach any horizontal line, we approach a slant asymptote, like so. Okay. All right, folks, that'll do it for now. We stop the share, check the chat. How are you getting the horizontal asymptotes? Okay, so let's see if I can get all these. All right, so horizontal asymptotes, and by behavior leading term. Okay, so something similar. Okay, how do I get the Y-intercept in problem 21? Get back to that. Okay, Y-intercept means you plug in X as 0. Okay, so X is 0. Put a 0 here, 0 here, 0 here, 0 here. You pretend it's not even there. Right? This is 0. Cover that up and cover that up. So it's -1 times 2, -2. The bottom will be 1 times -3, which is -3. So it's -2 divided by -3, which is 2/3. So just put a 0 here, 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 here. Okay, that's an answer to that. Okay, so questions about the horizontal asymptotes and end behavior. Okay, so very quickly, if I have the degree of the numerator smaller than the degree of the denominator, like this one, right? This is degree 0. This is degree 1. The bottom's going to win, quote unquote, in the long run, so the ratio is 0. Same thing for this one. The ratio is 0. For super big X, it's 3x over x squared, which is like 3 over x, right? And 3 over x, when x gets big, the bottom wins. So again, the ratio is approximately 0. So y equals 0. Now, if they are of the same degree, like 21, same degree, for super big X, it's 2/3. It's basically 2x squared divided by 3x squared. So the horizontal asymptote will be y equals 2/3 in that particular case. Okay. So that's what we got. Okay, and I think that's it for the chat. Only a few minutes left. Anybody else with something? Otherwise, we can call it a day. All right, that'll do it for today, folks. All right, so everybody have a good day. Stay cool. It's a hot day. So we'll see you tomorrow. All right, have a good day. Bye.